In the case of human-centric functional modeling, the conceptual space is a graph in which all edges are composable from, or spanned, by a closed set of four reversible functions, where that graph is suspended in a three-dimensional physical space. Since there are other conceptual spaces that are highly multidimensional rather than three-dimensional, a good way to get a concrete understanding of this conceptual space is to consider how it would be navigated. The conceptual space itself is just a graph independent of any means of implementation. But in the implementation of this graph, every concept is navigated with the help of a functional neuron. This functional neuron would discern some set of neighboring concepts as its context of execution, and would then execute one of the four reasoning functions or their inverses. This would result in navigating the conceptual space with whatever reasoning process of that type was most fit in maintaining the stability of the cognitive system's dynamics in its fitness space. One of the four reversible functions of the functional neuron is F4, or controlled detection of sequence. If the function executed was controlled detection of sequence, the reasoning process that would result would be an instance of System 2 reasoning. This implementation is monosemantic in that each concept is navigated by a single functional neuron. The actual System 1 or System 2 reasoning executed might depend on factors that are not yet adequately modeled within the semantic representation, perhaps such as which other concepts were recently navigated and are therefore within the context of execution within which that functional neuron executes its reasoning. The following animation aims to capture this. Any implementation of an intelligence that navigates the conceptual space is likely to be monosemantic in that each concept is represented by one functional neuron. In this animation, the execution path of reasoning has reached a specific concept in the conceptual space. Concepts that are within the context of the path of reasoning are lit up in red. Zooming in, the concept implemented by that neuron resides in a conceptual space in which some other nearby concepts, perhaps those recently navigated, form the context defining how the reasoning of that neuron is executed. Any reasoning path through conceptual space has a set of input concepts, a set of output concepts, and a set of concepts that are neither input nor output but that are considered to be the context of the cognitive system's execution of that reasoning. This context might change for each execution of that reasoning. In this depiction of conceptual space, the concepts within the context of execution of a set of reasoning paths are represented by the red squares. The same reasoning function F4 might then have a different outcome when the context is changed. If a single concept is navigated by a single functional neuron, then collections of functional neurons might cooperate to navigate collections of concepts. A general collective intelligence platform can potentially be viewed as orchestrating cooperation among individuals and/or intelligent agents that are each assigned to process some subset of concepts and/or reasoning, so that they might cooperate to navigate the collective conceptual space with collective reasoning. Current models of federated intelligence operate in ways that are not transparent, and therefore are difficult to map to these human-centric models. However, that mapping must be made if the lessons learned from implementing federated intelligence are to be reused in implementing a general collective intelligence platform, and vice versa.